Hello and welcome again to Amazing Maths. So this is a fifth video in the prime time series. So let's get started. So we have learned about prime factorization. How to check whether two numbers are co-prime numbers using prime factorization. First, do the prime factorization of both the numbers. There are no common, if there are no common factors, prime factors, can we conclude that they are co-prime? Yes, we can say that if there are no common prime factors between two numbers, then the two prime numbers are co-prime numbers. We can also test divisibility using prime factorization. Let's see the steps. First, same as the previous step, we have to do the prime factorization of both the numbers. Now we have to see if one number is divisible by another number, the prime factorization of the second number is included in the prime factorization of the first number. So we'll see what it means using some examples. So let's see whether 168 is divisible by 12. So first we have to do because larger number will be divisible by the smaller number. So first we'll do the prime factorization of the larger number. Then we'll do the prime factorization of the smaller number. Now, since we can multiply in any order, now it is clear that we can rearrange and write it 168 as 2 into 2 into 3 into 2 into 7. We rearrange the prime factors. It doesn't matter what order we arrange the prime factors of a number, right? Before we saw that. So if we rearrange that 168's prime factors, we get 2 into 2 into 3, that is 12, into 2 into 7, so 12 into 14. So using prime factorization, we saw that the prime factors of 12 are included in the prime factors of 168. So it is, the 168 is divisible by 12. So let's see another example. Is 75 divisible by 21? So let's do the prime factorization of the bigger number, that is 75 is 3 into 5 into 5. 21 is 3 into 7. So are the prime factors of 75 including all the prime factors of 21? No, right? So if 71 was a multiple of 21, then all the prime factor of 21 would also be prime factors of 75. However, 7 is a prime factor of 21 but not a prime factor of 75. Therefore, 75 is not divisible by 21. Let's see another example. Is 42 divisible by 12? So let's do prime factorization of 42. 42 is 6 into 7. So 6 can be further divided as 2 into 3. So prime factors of 42 are 2 into 3 into 7. And prime factor of 12 are 2 into 2 into 3. So all the prime factors of 12 are also prime factors of 42. But the prime factorization of 12 is not included in the prime factorization of 42. Why? Because there is one extra 2 in 12. But 42 has only one 2. So 42 does not include all the prime factors of 12. So let's do some figure it out from the chapter. Are the following pair of numbers co-prime? Guess first and then use prime factorization to verify your answer. So 30 and 45. What is your guess? Let's check. So let's do prime factorization of 30. 30 is 2 into 15. So 15 can also 2 into 3 into 5 we can write. 45 is 9 into 5. So 3 into 3 into 5. So they have a common factor, right? So they are not co-prime. Because they have a common factor, they cannot be co-prime. That by definition of co-prime numbers. Let's examine the second pair. 57 is 19 into 3. 85 is 5 into 17. Do they share any prime factor, common prime factor? No. So they are co-prime. Number C is 121 and 1331. Both are powers of 11. One is 11 square, another is 11 cube. So definitely they share common factor, prime factor. So they are not co-prime. The last pair, 343 and 216. Both are cubes. One is a cube of 7 and one is a cube of 6. So 243 is 7 into 7 into 7 as 7 is prime. 216 prime factorization is 2 into 3, 2 into 3, 2 into 3. All the 6 into 6 into 6 we further divided into 2 into 3. So the prime factors are all these numbers. So do they share any common factor? No. So they are co-prime. So let's see the second problem. Is the first number divisible by the second? Use prime factorization. So A, 225 and 27. We prime factorize 225. 225 is 15 square. So 3 into 5 and 3 into 5. And 27 is 3 cube. So 3 into 3 into 3. So what we see is that 225 has 2 threes and 27 has 3 threes. So all the prime factors of 27 are not included in 225. So 225 is not divisible by 27. What about 96 and 24? These are the prime factors of 96. There are 5 2's multiplied by 1 3, and 24 there are 3 2's multiplied by 1 3. So by rearranging the factors of 96, we see that all the factors of 24 are included in the yellow box of 96. So 96 is 24 into 4. So 96 is divisible by 24. So let's see the C1. C is 343 is again 7 cube and 17 is a prime number. So 17 there is prime factorization is only 17. So it's not included. So it is not divisible by 17. 999 and 99. So 999 is 3 into 3 into 3 into 37. And 99 is 3 into 3 into 11. So we see that it is not included. All the factors of 99 are not included in the factors of 999. So 999 is not divisible by 99. So the third problem is first number has a prime factorization of 2 into 3 into 7 and the second number has prime factorization of 3 into 7 into 11. Are they co-prime? Does one of them divide the other? No, they are not co-prime as they share two common factors 3 and 7. So they cannot be co-prime by the definition. Does one of them divide the other? No, as no one contains all the factors of the other, none of them divide the other. Let's see the fourth problem. Guna says any two prime numbers are co-prime. Is he right? What do you think? So yes, Guna is right. Primes have only two factors, 1 and itself. So any two prime numbers have only one common prime or common factor as 1. So they don't share any other prime factors. So they are co-prime. Always two primes will be co-prime. So that's all for today. Please like, subscribe and share.